In example 1, we're going to be finding the percent of a number, and they want us to figure out what 25% of 40 is, to figure out what number that is. And so we're going to, first of all, take a look at what we can do with common sense math. So if we're talking about 25% of the number 40 here, we know that the answer we get is going to have to be quite a bit less than 40, because if we think about percentages, 25% is only about a quarter or a fourth of the whole amount. So we know whatever our answer is needs to be about a quarter or a fourth of 40. So the first thing we're going to do here is we're going to use this expression, percent times the whole amount should give us the part that we're looking for. Step 2 is that we are going to write that percent as a fraction, and 25 over 100 is our percent, 25%, and then we can divide both of those by 25, and that's going to give us 1/4, and then we are going to multiply that by the whole amount of 40, which you can write like that, or remember you can also write that right away like a fraction here. And in our last step, after we wrote that percent as a fraction in simplest form, we're going to go ahead and multiply. And just like we have practiced so many times this year, we're going to practice cross-simplifying first. I know that I can divide both of those numbers by 4, and that 4 divided by 4 will give me 1. 40 divided by 4 will give me 10. So when I rewrite that, I have 1 over 1 times 10 over 1, which we know is the same thing as 10 over 1, which is equal to 10. And so when we go back to what we were talking about when we first started this problem, the question is 25% of 40 is what number? And so we said it was going to have to be less than 40 because it would be only about a fourth of it. And 10 is, in this case, exactly a fourth of 40. So it matches that prediction that we had made at the beginning of the problem. For example 2, we're going to find the percent of a number, but this time we're going to use a ratio table, and the question we're solving is 60% of 150 is what number? And again, I really do want you to keep that common sense prediction in mind, so that common sense math, and we know that half of 150, which would be like 50%, would be close to 75, and that's just kind of using estimating there. So we know that 60% of it is going to be a little higher than 75. And again, I just want you to kind of keep that in mind as we go through the steps to make sure that you're on the right track when you get all the way done. So it'll be higher than 75, and we'll check that in a little while. So when we set up our ratio table, we're going to use one row to find or to represent the part of the whole and the other row to be the whole. And then in this case, we're going to find an equivalent ratio to 150, where 150 is the whole number. So let's look at how that gets set up. So this is what your ratio table might look like. And again, the part being the first row, the whole being the second number, and we know all percents are a part to whole ratio, so 60% is the part and the whole amount of the percent would be 100, and we're going to try to get to 150, but since 100 to 150 doesn't have a direct jump, we're going to have to find that equivalent ratio in the middle. And remember, if all else fails, you can get down to 1 as your denominator, but in this case then you're going to get into some tricky parts with 60 not going in evenly. So instead, try to look for a common number that 100 and 150 might have that you could work from. And in this case, I am going to get down to 50 because I know I can go down to 50 if I divide 100 by 2. And then if I divide 60 by 2, that's going to give me 30. And then to go back up to 150, I would have to multiply that by 3, so I can do the same thing up here and get to 90 by multiplying by 3. And then to answer our question, that would tell us that 60% of 150 is 90. And again, if you go back to that common sense math or that prediction that we made earlier, we said that we knew half or 50% of 150 was going to be around 75 and that 60% would be a little bit higher. And we can see that 90 is a little higher than 75, so it fits with our original prediction. For the on your own problems this time, I'm going to let you pick 2 of these 4. You're always welcome to do all 4, but you have to pick at least 2. But you do have to make sure you explain your method. So you have to show your work to explain that you're either using the fraction method and kind of show the steps that you're using for that, or that you're doing the ratio tables and show your steps for that. And you can do one of each, or you can do both the same way. That's up to you. And again, your method choice might not match what I show. For instance, on this first one, I picked the fraction method and I show all my steps for that. But if you chose the ratio table method, that's okay as long as you show all your steps. But what should match is your answer. So make sure you get the same answer as I do, but if your steps don't match because you did the other method, that's okay as long as you can explain your thinking. For the next couple of examples, we're going to find out that you can use a related division equation if you know the percent of a number and the part, but you want to find the whole. And in order to do this, I first want you to think about it just using whole numbers. Then we're going to add the percents in. So you already know that 3 times 12 equals 36 is related to the phrase or to the expression 36 divided by 3 equals 12. And we know that we can just kind of move these parts around, and as long as we keep those all in the same fact family, then we can have those opposite operations and we can still find out our information. So the next key idea here is that if you know the part and you divide it by the percent, it will equal the whole amount. So if we take something like this, and if we knew 20% of the whole amount of 60, and we wanted to figure out what the part was, that's what we did in examples 1 and 2, we could turn 20% into a fraction in simplest form. It would become 1 over 5, and we could multiply by the whole, and it would give us a total of 12. But in these next 2 examples, we're going to do things using that related division equation that we mentioned, and we know the part is 12, and if we divide it by the percent, okay, so this time we know this one, and we're trying to figure out the whole. If we divide it by the percent, we're still going to turn that percent into a fraction in simplest form. We're going to keep that 12, but turn it into a fraction. And then we're going to keep in mind that dividing fractions means we need to keep, change, flip. So we're going to keep the 12 over 1, change division to multiplication, and flip 1 over 5 to 5 over 1. And then we're just going to multiply straight across, and we get 60. And we can see now that if we put that in there, that we've got those 2 related fact families. Here it was 20% of 60 is 12. Here it's 12 divided by 20% equals 60. We're going to get some practice, so just keep following these steps. In example 3, we're going to practice finding the whole number when we know the percent and we know the part. And so they ask us to find 75% of what number is 48. And another way to say that same thing and put it in the order closer to what we're looking for is that 48 is 75% of what number. So again, if we go to common sense math, 48 has to be smaller than the number that we're looking for because it's only 75% of the total. So that means we're looking for a number that's going to be bigger than 48, and we're going to use that set of steps that we just wrote down in our key idea. So step 1 for finding the whole is to use this expression, part divided by percent equals whole. So in step 2, we're going to write the percent as a fraction, and again, we're going to go for simplest form. So we know that 75 over 100 can both be divided by 25, and that'll give us 3/4. And our formula still says 48 divided by 3/4 because our part was 48, our percent was 3/4. And now we're going to try to find the whole. Step 3 is going to be to divide, and remember when we divide with fractions, we've got to keep, change, flip. So we're going to keep 48 over 1, change that division to multiplication, and flip 3/4 to the reciprocal of 4/3. Still a very good idea, very important idea to see if you can cross simplify. And I can in this case. If I divide by 3, that brings it down to 1. And if I divide by 3 up here, it's actually going to give me 16. And then I'm really dealing with 16 over 1 times 4 over 1, which is going to make multiplication a lot easier. And when I do that, I get 64 over 1, which we know is the same thing. And again, we check our common sense math out from what we talked about earlier, and we had said that 48, because it was the part, was going to be, since it was only 75% of the amount, it had to be smaller. And so that means when we say our whole amount was 64, that 48 is less than 64, so it makes sense. For example 4, we're going to find the whole number using a ratio table this time, and they ask us to figure out 120% of what number is 72. And again, we can think of that this way. 72 is 120% of what number, because it fits our formula a little bit better. And again, common sense tells us that 120% is more than 100%. So we're going to want to keep that in mind when we're coming up with this. But we're going to go ahead and set up that ratio with part as one line and whole as the other again. Now this one's going to look a little bit funny for a couple of reasons. First of all, the part compared to the whole, the part is already bigger, but that's because they told us it was 120%, and 120 over 100 is how you would write that in the part to whole ratio. And then this time, instead of knowing the whole amount like we did in example 2, we're going to try to get to this part amount, but again, we're going to try to find an equivalent ratio in the middle. So we're going to try to find something that 120 can have in common with 72, and we're going to pick the number 6 this time, because if I divide 120 by 20, I know that 12 divided by 2 gives me 6, and just put the 0 on. And then if I divide 100 by 20, it will give me 5. And then to go up, I know that 6 times 12 will give me 72. So I could do times 12 on the bottom, and 5 times 12 is 60. So this is the number that we're looking for, and basically that's filling in the statement that we made up here. 72 is 120% of 60. Whoops, let me switch that to the writing function of 60, and it makes sense again because 72 is a bigger number than 60, which is what we were looking for because it was 120%, which was more than 100%. And again, you can do that using the ratio table, finding equivalent ratios, and we will practice this more in class. So once you get a few practice problems under your belt, I think it will come a little bit more easily. This is the answer if you choose to do the method like we did in example 3, and I'm also going to show you if you chose the ratio table method as well.